Thank you for coming. It's so good to see you here. I'll say a few words about myself. So, hey, who am I? So, as I was told, I work for ImageLine as a software developer. I'm responsible for 13 kind of legacy plugins and also build system of FL Studio. Also one of the team member of Composer Summit Prague. We do this event for like media composers mainly, and I'm also a keyboard player. Before COVID, I toured a lot, played some interesting halls and such. As was mentioned, I have history in audio development already. Before joining ImageLine, I worked with Audified, which is like small Czech brand developing like custom stuff. One of the project I was working on, I'm not in the picture, but I was working on this player, which was for like a player for theaters. It has some specific like requirements. And also I worked for medical. I worked, for example, on Caroling SmartSync device manager, which is like an iPad pad which communicates with either medical devices or pacemakers. I was on a team which was working on low latency drivers. Okay, cool. So let's start with the end. There is this case study. I'm not sure whether you're familiar, probably you are. Who of you already heard about Finale and its story? Okay, it's kind of sad story. Who don't know Finale? Finale is like music notation software which was quite popular, but unfortunately, like a year ago, it was cancelled, like stopped being developed. So yeah, it was released in the late 80s. It became like gold standard for like music notation, and actually a lot of composers really like it for its versatility. If you are an avant-garde composer, you do some crazy stuff like they do. You probably were using Finale because it has like really strong features in case of you wanted to do highly custom stuff. But unfortunately, it was discontinued. And this is the famous post on the internet. And as I highlighted here in this paragraph, the reason that it was presented was basically the technical debt. That the technical debt made incremental updates quite impossible over time. So if you want to hear more about that, there is this really cool video by Tantacrow. I'm not sure whether you know him. He's like the designer with the Muse group now, and he works on MuseScore and Audacity. And there's like almost over an hour long video where he explains why this happened with Finale. So some takeaways from that, as I told, obviously the code base was very old and complex. The team, as is presented in the video, planned some major refactoring, but for some reasons, which I will not like explain in detail, please see the video, it wasn't possible. So it kind of died. Okay, but what we can hear, what we can like learn from that is that if we ignore technical debt, it can seriously damage or kill our business. So to avoid that, there must be effective communication between the engineering team and management needs to be aware of this kind of stuff, that actually technical debt can kill their business eventually. So the goal of what we want to do is actually, yeah, it's a legacy code, right? So probably we won't make it perfect, but what we want to do is to have effective incremental updates, which basically killed Finale. They were not able to do that. So what we did, or what I'm working on, is this is some of the plugins which are my responsibility. There are 13 of them, not all of them are on the screen. And as you can see, some of them are, or most of them at this point, were using the bitmaps or pixels, which, as we heard yesterday in this brilliant talk by Julian, it's not like way to go, so we heard that. And also, some of those plugins were originally released as audio units or VSTs. FL Studio has this own like plugin format, so we are like closed ecosystem, but people were still using it, so they needed an update. So we did that. There's like brief like summary what happened, and currently what's going on. We are transforming the old GUIs to new vectoral ones. So the rest of the talk will be a mix of memes, some theory, and learned lessons. This topic can be quite boring. It's a legacy code, so I wanted to make it as much fun as possible. So let's groove into it. First meme, you earn it. I think everyone in engineering can relate to that. Cool. So let's have some definition. I use Wikipedia. You can read it on the screen, but as I was reading it and different definitions was that I was quite surprised that legacy code is still in use because it kind of still brings some value. If it wouldn't be used, right? So let's look at it this way, that the legacy code is not all bad. There's something good in it. And the reason why is it legacy is that it uses like old libraries, old like paradigms and such. So it's quite difficult for engineers or developers to work with the code base. And there is no like tests or very less of them, and it's very difficult to make any changes. Okay, so just to get a lay of the land, I've just heard that some of the parts of the contact code is maybe older than that, but if you started around the time, you're probably using code which is like 20 years old, which is like kind of a lot. And as Julian already pointed out, VST3 is 17 years old. It's like teenager, right? So interesting. So just to compare it, 20 years ago, we had Windows XP, we had FL Studio 6, Cubase 4, and iPhone 1. I believe no one is still using iPhone 1 unless it's like some kind of geek or something like that. Cool. The pain. What are the main traps of the legacy code bases? Obviously, difficult in maintenance and modification, technical debt and complexity, risk of causing regressions. Yes, because I will be talking about that later. We don't know what we don't know. That's basically the problem of the legacy code base. We are often afraid to make any changes because we are afraid what these changes will cause. And obviously, lack of documentation. If we had the documentation, we probably have done it already. Cool. More pain. There are obviously usually some integration problems with new frameworks or libraries. The code is usually like very coupled with other components. Also, it's kind of hard to upgrade the code for new processors. So you've got really old plugins which doesn't support M1 or ARM architecture on a Mac already. You know about that. Obviously, security vulnerabilities. Okay, so let's ask another question. Why this can happen? There's this guy, Joel, which is the founder of Stack Overflow. God bless him for that. And he wrote this one blog post, which is called the Duck Tape Programmer. And I'll read it because it's just incredible. At the end of the day, ship the freaking thing. It's great to rewrite your code and make it cleaner. And by the third time, it will actually be pretty, but that's not the point. You are not here to write code. You are here to ship products, which kind of is true. We are not usually hired to make Mona Lisa source code or something like that. We are here to actually bring value to company. Sometimes developers forget that. Sometimes then they don't, and it ends up like that. So we should write the code efficiently, yet we shouldn't shoot ourselves in the foot. So, and basically, these are the results of that. We already know this. Okay. Another meme. You earn it. Yeah, that's basically the previous slide, but on picture. Cool. So we asked why developers do that. So why companies? So usually there can be like resources constraint, either financial or there's like not enough people. There's also risk of business disruption. It depends on the project or the product, or also it depends on your infrastructure, how it's like deployed. Uh, if you're start rewriting like really backbone part of your system, it can like potentially like delay some really important features for the customers, and it can affect your business. Uh, Often it can be like misunderstood maintenance cost because it looks cheaper to use what we have, but in the long term it can, well, we see finale, right? And legacy code works kind of well enough, but it shouldn't be the reason to like stick with it forever. Cool. Another meme. 2 memes in a row. You're lucky. I think everybody can relate to some point. Okay, so how we do that? Let's ask more questions. The first question is, where are we? Yeah, basically, we are not set up for a win because if we were, it won't be a legacy code, right? So this is also my favorite. Understanding legacy code is much like trying to decipher an ancient manuscript. It requires patience and keen eye for detail, and a deep understanding of the programming language and the software architecture used to write the code. Software developers who work with legacy code need to understand the nuances of the code to ensure that it continues to function as expected and can be extended and evolve as needed. Cool. Yeah. Kind of. There won't be that much memes, but it kind of felt good to place it here. Okay, so where are we? We know that we don't know, so it's a kind of philosophical question, but it's true. But let's find out what we actually know. We have release binaries, so we kind of have the reference implementations before we start making changes. So we usually can choose the last one, or we can choose like different reference implementations for different features which we like. It's also good to keep like track of all these releases because sometimes nobody knows if it's a bug or is it a feature, and when it actually happens, there's like this blame shifting thing, right? STM, I mean, this is gonna be your best friend. If it's a legacy code, we usually don't have like very good user doc, like technical documentation, but we do have user documentation, and the more detailed it is, the more value it can bring to you, because sometimes there's like this little button in the third hidden menu, which actually nobody uses, but somehow it's important for some other part of the code which you need to refactor, but you don't want to like rewrite 3,000 lines of codes, so it's better to read the user doc. If you have a backlog, do a backlog audit, because it contains some of the information, maybe not all, but it can give you like lay of the land. Tests, are there any? If it's like very old product, there may be like no automated tests, there are no like automated tests, but you can create test projects. If it's a plugin, you can like create one test project for like extreme values, like all low values, the next project for like max values. If there's like a switch with multiple steps, you can test edge values, you can test automation. There's like almost infinite possibilities. Presets are basically test data for free. And know-how, if the author is not around or doesn't remember, which is also a possibility, sometimes I don't remember the code which I wrote like a month ago. So if he wrote it like 10 years ago, it's probably he doesn't remember either. But other on team may have some knowledge. Okay, one of my teachers at uni, he had this saying, if you can't measure it, you can't manage it. So if it's really old code, there are probably no metrics, but there are some few things we can all actually do. We have got source code management history. This is gonna be your best friend. Source code management is gonna be your best friend. Is there any logging? If so, try to understand it. I will talk about it later as well. You can try some UML or documentation generation tools, but it might not work well in very complex code. Compile warnings is basically information about problems for free. Static analysis, dynamics analysis, we know that AI tools, let's leave it for later. Okay, next question. Now we know where are we, so let's decide where we're actually going. So, as I already mentioned, the goal based on the Finale story should be effective incremental updates. So the transformation of the code base should help ship better products faster. Better means fewer bugs, less memory leaks, less crashes, new features. There's like infinite possibilities, right? Faster means CI/CD and the code is testable. We also need to like define key targets of the transformation. Does the engine of the plugin needs to sound the same? There was a great talk yesterday about Lady from Native Instruments, and they actually ported some of old reverb code from exponential audio to their code base. So I'll refer to that. Find it on YouTube later. How strict are we going to be about backward compatibility? Because sometimes, is it a bug or is it a feature? If I want to add this new feature, I need to change this, but introduces this new bug. Well, which new features we do want to add? Well, there's no like correct answer to that. It depends on the project. Let's do another meme. Yeah, it basically says that the refactoring should make the code better, which usually developer wants to do that, but it's not always the case, right? Okay, how do we get there? Are we there yet? Oh, we've got 20 minutes. That's cool. So this is basically how I did it. My favorite saying is that there are many ways to skin a cat, which basically means there are different approaches to a problem. So SCM, I will talk about it a bit later as well. Super important. Freeze the current state. Already talked about that. Updating DevTools and SDK can sometimes fix issues which you have in the code base because these updates already has these fixes. And build log audit. So this is basically a sum up. Phase 2, basically now we have the code base ready for some major changes because we feel secure enough that we know what's actually supposed to do that because we have a reference implementation and we have source code management history, so we can track our changes. And yeah, we already know that, but let's highlight it a bit more. CI/CD, automated testing, and nightly builds. Nightly builds gets you daily updates on the health of your code base. If you're starting with a really old project, there is like no CI/CD, at least write a script that builds all the projects or the project at once using one command. It will help you clean up, and refactoring is the next step. And then we kind of feel like secure or good about the changes, we can add new stuff. Okay, let's talk about more about Codebase Refactoring. So it basically feels like that. So brace yourself, sorry. So refactoring is the process of changing a software systems in such a way that it does not alter the external behavior of the code, yet it improves its internal structure. It is an essential practice when working with legacy code. Before making changes, take the time to understand how the code works, its dependencies, and how it interacts with the other parts of the system. This will help you make changes that are safe and effective. Kind of common sense, but yeah. Another video by Tentacle. This guy is amazing. He also made a video how they are redesigning Audacity. It's almost an hour long. And one interesting thing which really stood out was that the team actually decided to have like, I've got it in the next slide. They call it pre-production planning. So as I understand it, it's like basically the time that they spend time with the code base, trying to few things to actually figure it out, what is going on before actual planning and before actual work. Yeah, basically, most of the stuff I've already said. We need to have like real clear design direction. We need to know where we are going, but we don't know what we don't know. So expect that there might be some changes as you discover new stuff. Yes, source code management system. Practice high granularity commits. Each commit should be meaningful and self-contained and ensure that each commit builds successfully. This is the most important thing ever during the refactoring, because I'll promise you that in the future, like few weeks from now, you will face some issue and you will be like, well, I kind of didn't change this code, but why is that it's not working? So you try logging, you try debugger, it doesn't help. So basically you start going back in the SCM history, either it's JIT or SVN or something else, but this will save your life and hours of development and lots of your errors. Okay, cool. So new formats or new like standards of the C++. I don't think it's a good idea to force new standards on a legacy code base because it can add another degree of human error. So unless it's required by external library or third-party code which brings a value, I wouldn't force it. But if it's like super old library, it's like pre C++ 11, I really consider upgrading at least to C++ 11 because smart pointers are at that point of time part of the code or the standard library. If you are using newer C++, override and no discard is gonna be your next best friends. Okay, last night we also heard about CMakes. Everybody uses, but everybody hates it. But sometimes it's not an option for legacy code for some other reasons. But Xcode and Microsoft Visual Studio offers an opportunity to actually share configuration for different projects between themselves. So it's useful if you're dealing with multiple plugins. If you find code which you don't understand and you read it like and trying to understand for more like than 5 minutes, write a comment. Okay, refactoring. Sometimes you don't have to change the overall architecture. Sometimes it helps it just rename the function, rename the class, because as the code evolves, different developers works on that, and they use different approaches. And now the GUI does something, but the class in the source code is kind of has a different name. So what's going on? Maybe the user doc is not updated, so it has some other naming. So actually, this helps a lot. You can use some kind of advanced-ish Unix stuff for renaming classes or variables. For example, this one should find a variable or like a pattern which is like m_voice character time, and it renames it so it keeps the original character in place, but replaces all other characters around. Yeah, incremental releases, don't try to do it at once. One step at a time is also important approach here. Okay, another great talk by Roth Michaels. He gave a talk about C++ legacy code bases within native instrument group. He has a bunch of great insight as well, so highly recommend it. Cool. So AI tools, are they a good idea? So for me, the highlight of the yesterday talk, which Julian had, was if you want to use an AI agent, ask yourself, do you need it? If you need it, it's not a good idea to use it. If you don't need it, it's gonna be fun. So the thing is that there are these studies. I attended this Prague DevOps meetup, and there was this guy who had this talk, and he presented these like researches which were really interesting to me. So we are like message with like Microsoft and OpenAI, like marketing teams that use this super cool new like language model which helps you deliver products faster. But as some research has proven, it's not always the case. For example, working on an open source code base, the developers who were experienced were actually slower with an AI. And the thing is that the AI generated code also introduces more vulnerabilities and design flaws. So if you have if you have code which we don't understand, which we know it's badly designed, is it a good idea to use a tool which will change the code? We are not 100% sure that the code will be, after the change, 100% correct, and there is no one in the company who will tell us it's right. I mean, well, you can answer it for yourself. Cool. Another meme. Yeah. Um, Also, when I was working on Metronic, one of the coding standard was that the code shouldn't have any dead code. So maybe that's a good idea to remove like unused code as well, because the more code you have, it's like more confusing if you don't know what it actually does or what it's actually doing. Okay, debugging and logging strategies. How not to get lost. Okay, this one is my favorite. So obviously, ancient Romans were using log files, and Leonardo da Vinci invented unit tests. But yeah, it gives us like great overview of like possibilities what we can do. So one thing is don't be afraid of logs. When I was working on Medtronic devices, we were using logging a lot because when you deploy the product, it was in production and doctor was using it and something doesn't feel right. He reported to the vendor. He reported the issue to the vendor, and then we downloaded the logs and we read it through. Before that, I wasn't really that familiar myself with reading and using logs, but this was like a great uh, opportunity to learn that. Sometimes the logs were like 5 MB, sometimes it was like thousands of lines of the code, like or logs files more than 100 like megabytes long. So in this case, we're dealing with a legacy code base, logging can help a lot. It helps me a lot. It depends on your workflow, but I personally do like it, although it's like ancient Roman stuff, as we figured. You need to know what you're looking for, though. So it's quite difficult to use logging when the application or the source code is very new for you, but you can add your new log messages to help you understand what's going on. And unlike the debugger, you can see all the things at once. You don't have to like use any keyboard shortcut to make the arrow move to another line of the code. And if you're advanced Vim user, you can like you can like close Vim, so you can use it to filter all the unnecessary stuff. And also you can log audio signal data and then use like Spider or whatever to help like look through any DSP problems. So this is example of the log I'm using. So there's obviously date and time, thread number, plugin format, name of the class, line number. Then there is method name and some logging messages. So, and if you're using Vim or any advanced like text editor, you can like easily remove, for example, or lines of code which are before a certain time and so on. Cool. Great. So for that reason, I wrote a custom logging library. It's not a real-time or real-time save, but when you're working on some crazy bug and you're like deep into the code, you now figure it out that there's no logging. The project doesn't have any logging library. So I wrote kind of easy logging macros, which are just in one header file, so you can just include it and you can like continue with that. Okay. Yes. But if you want some real-time stuff, there are also some great resources. There is this like masterclass in real-time logging by Devendra Parak from Waves. I was there in person. It was amazing. And there is this short talk by Chris Apple. It's great as well. Cool. So how we get there? Plugin validation. FL Studio has its own like plugin format, so we have like our own test suite. You can run it actually if you open FL Studio. It's like I think it's view, tests, and run. It's like smoke test for our application. But if you're using another plugin format, but probably you do, there are other tools. AUL obviously. There was a problem that you couldn't run AUL via remote session on another server during build session. So because the AUL didn't see the actual audio unit, it saw only default Apple stuff. If you figure it out, please let me know. Plugin AUL was also mentioned last night, the must-have tool for automated tests. There's also Plugin Doctor. and VST3 has a VST3 inspector. So if you haven't seen plugin already, it looks like that. It can also run without GUI inside your build pipeline. And if you're a plugin developer, this is the least you can do, and it saves you a lot of lonely nights. And there is also Plugin Doctor, which basically helps you figure out all DSP problems. This is one of our old plugins. Cool. Debugger is an obvious choice, but sometimes the software which hosts the plugins is like code protected, so it's not like always possible to debug it using the debugger. That's why the logging is really important. Resource monitoring is also a great idea. There is this app which is called, I believe, Resource Monitor. I remember using it one time where I was integrating the library, which kind of did nothing in the release, and in debug it kind of crashed it. But the reason was it was looking recursively in other libraries or in other folders for dependent libraries, which sometimes he found, sometimes he didn't. It was kind of crazy stuff. Vim is my best friend. It helps you a lot. And I already mentioned that grep, awk, and set can help you with refactoring, but also navigating the source code like from the high-level point of view. If you're like blob of data, it helps a lot. Imhex is another great tool. I'm not sure, does anybody know Imhex or uses Imhex? Okay, not many, actually no one. It's open source, a hex editor, and the one most brilliant feature it has its own markup language. So what you can actually do, you can, using this language, which kind of feel like C, C++, you can describe the binary data. And when you load a binary file, you can actually point it to like specific address within the file, and it parses the data. So if you're debugging, for example, some presets, loading and saving, this helps a lot. For example, you change the GUI, but for some reason, this one knob doesn't like saves or loads this value properly. You can like easily have a look. It's my favorite. Okay, Audacity, it can do per sample views. That's also great. Long time no meme. Cool. Vectoral GUI modernization, I'll be quick. So yesterday, the talk was amazing. Better scaling. What to add, right? The editor and engine must be strictly separated. We know it since VST3, but before that, we didn't know that. So if the code is really old, the first thing you need to do, you can use like hex, like internal parameters, like parameters with like negative index numbers to address some stuff. You can use like custom engine interface for communication within the GUI. Watch out for parameter range changes and different types. Sometimes the code and old code uses like unexpected types, so they can be some kind of crazy and mind-boggling routing errors. We also introduced new preset format, which is kind of FL Studio specific. I won't go in much details, and keep the old GUI editor for working for testing and debugging as long as possible, because you need some kind of reference implementation. So I already mentioned that. Okay, CI/CD. This is just a sum up. Also, backing up all the build artifacts also help when it tracks any changes. It's basically like history of SVN, but alive. Okay, so I repeat it one more time. The goal of the transformation shouldn't be like the most perfect, cleanest work base, because if it is, I would suggest to start like from scratch. But the goal should be effective incremental updates, and how we do that one step at a time. That's the end. Thank you.